Yeah, welcome to Excel Class Hub. I'm Mr. Adekunle Samuel by name. Here I'll be taking you capacitance of a capacitor. Capacitance of a capacitor. But first and foremost, what is a capacitor? A capacitor is a device used for storing electrical charge. A capacitor is a device used for storing of electric charge, which consists of two plates, which are the positive and the negative. But we can still go further saying types of capacitor. We have types of capacitor. I can still give you three types of capacitor. Number one, we have what they call the variable air capacitor. Two, we have what they call the paper capacitor. Why the third one, I can still give you again, we have what they call the mica. We call it mica. It is called the mica capacitor. But it's up to 8. But I decided to give you 3. But coming back to your capacitance of a capacitor. What is capacitance of a capacitor? In short form, any formula in physics, you see in physics, any formula in physics, we got to through the definition or law. I can use definition to get my formula, and at the same time, I can use law, getting my formula. Capacitance of a capacitor can be defined. Capacitance of a capacitor can be defined as charge per unit potential difference. In a nutshell, this is the capacitance of a capacitor. We said it can be defined. It can be defined mean equals to as charge per unit. Anything per unit means over potential difference. Potential difference. Let's take a look at the symbol. Capacitor is denoted as C, which is C. While this charge is denoted as Q, and my potential difference is V. So this is your formula for for capacitance of a capacitor, which is charge per unit potential difference. But one thing again you have to notice that you see this capacitance of a capacitor is always measured in farad, which is the SI unit. It is measured in farad, which is F, which is the symbol for farad. Whenever you see a teacher writing something like this, 2 farad, that means he's talking about capacitance of a capacitor. And at the same time, you can still see a teacher writing something like this, 2. This sign here means macro. We call it 2 macro farad. This is called 2 macro farad. Whenever you see something like this, 2 PF. This PM is pico. We call this P pico. But if you see something like this, 2 NF. This N here means nano. Nano. But if you have something like this, 2 MF. This M here means milli. Means milli. But let's come back to this. I said this your capacitance of a capacitor can be defined as charge per unit potential difference. But if I should make this Q subject of the formula, I'll have C equals to C is equals to Q over V. This one can give me over 1. From here, I cross multiply. Q times 1 will be Q. And you have C times V will be CV. So this is your formula to calculate charge between the plate. If you're asked to calculate charge between the plate, you have to use Q equals to CV. But if you're asked to calculate the capacitance of a capacitor, it can give you charge per unit potential difference. But at the same time, remember, I said this capacitance of a capacitor is measured in farad, which is F, which is this one here means 2 farad. So from this aspect now, we have what they call this capacitor with capacitor can be arranged in series, and it can also be arranged in what? In parallel. Let's take a look at this. Capacitance of a capacitor when it is arranged in what? In series. Capacitance, you have something like this. This is capacitance in what? In series. But remember, I said the symbol for capacitor of a capacitor is what? C. But this is capacitor in what? In series. You have C1, C2, C3. So this C1 is always across V1. Why this C2 is always across what? V2. And this C3 is always across what? C3. That is why if you go back to your textbooks, you'll see you'll be given a formula that this capacitor will be capacitor, that the formula is always 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over what? C3. I decided just to wonder, let me just prove the formula out first. If I'm to prove this formula out, this is C1 plus C2 plus C3. You find what? The total what? This C1 is across V1, C2 is across what? V2. And this C3 is across what? V3. Let's find, you can see that this V here is your what? Your potential what? Difference. If I'm to get the total potential difference here, total potential difference should be what? V total. Total potential difference will be what? V total. That means I have to sum all these things together. You have V1 plus V2 plus what? V3, which is your what? Your total what? Potential difference from the what? The circuit given above. So if we come back here now, this is V. If you come back to this, your capacitance of a capacitor, C equals to what? Q over what? V. From here, I decided to make Q subject of the what? Formula. But here, I want to make V subject of the what? Formula. If I'm to make V subject of the formula from this Q equals to CV, I will divide both sides by what? C. And I'll still divide both sides by what? C here. You can see that this C will cancel this C. What am I left with now? V equals to what? Q over what? C. Which means my formula for potential difference is what? V equals to what? Charge per unit what? Capacitance of a what? Capacitor. You can see this is your V here now. When you have this V, this is V. What is my V now? Q over what? C. So I can now change this thing, substitute this Q over C back as what? V. I will now have Q. I will have Q over C. Remember there's total here. You have this one, so you know this one's supposed to be Q over C also. But this V1 is across what? C1. It will now be Q over what? C1. Plus the next one will be what? Q over what? C2. Why the next one also will be what? Q. V3 is across what? C3. Am I communicating? You move further again. When you have this Q over C total, it can still give me Q times 1 over C total if I should expand it. That should be Q times 1, because Q times 1 gives you what? Q. And you have equals to, what is common to both sides here? Q is common to both sides. You bring the Q outside and you put it in a bracket. You have 1 over C1 plus 1 over C2 plus 1 over C3. Because if I should use this Q to open this bracket, if I want to open this bracket, this Q will affect everything here. Because Q times 1 over C1 will be what? Q over C1. Q times 1 over C2 will be what? Q over what? C2. Q times 1 over C3 will be Q over what? C3. Am I communicating? From here now, this Q can cancel this word Q. So your final answer will be what? 1 over C total equals to what? 1 over C1 plus 1 over C2 plus 1 over C3. So this is your formula for capacitance in series. Whenever you're told to solve a question, find the capacitance of a capacitor in series. Your formula is what? 1 over C total equals to 1 over C1 plus 1 over what? C2 plus 1 over C3. As you can see, I've proved the formula out. But you see this CT here comes out in different forms. From your past question, or if you're asked to solve a question, you may be asked to calculate the effective capacitance. Sorry, effective what? Capacitance. At times they may change it to what? Calculate the total capacitance. If they do not use effective, they may use what? Total. At the same time, they can still use equivalence. Equivalence. Equivalent to what? Capacitance. So this is your diagram for what? Resistance. Sorry, capacitance in what? In series. Which the formula is what? 1 over C1 plus 1 over C2 plus 1 over C3. Now, let's now we see what they call the capacitance in parallel. This one here is what? Capacitance in what? In series. Capacitance in parallel. Capacitance in parallel. When we have this diagram here, capacitor in series. But if you see any diagram like this, this diagram here illustrates what? Capacitance in what? In parallel. You can see that the diagram are not the same. Whenever you have anything straight, is in what? Series. But if you have something like this, is in what? Parallel. At the same time, this one can be C1, C2, C3. This one is across what? V1, V2, V3. While this one here will be across Q1, this one will be across Q2, and what this one will be across what? Q3. If you go back to your capacitance in series, we said we calculated the total what? Potential difference. But what we have here is what? Charge. So here now we need to calculate the total what? Charge. Which my total charge will now be Q total equals to what? Q1 plus Q2 plus what? Q3. Which is my what? My total what? Charge. Because here is what? Total what? Potential difference. But from this place, we have the total charge as Q1 plus Q2 plus what? Q3. You now go back to that your capacitance of a what? Of a capacitor where I gave you Q equals to CV as a formula. You can see that your Q is what? C what? V. I can now change this Q. When my Q is CV, I can change this Q back to what? CV. Remember there is total there. You put your total there, or you rearrange it. Can rearrange it. Since you can put C, this T can be here, and you have what? V. Equals to, what is my Q again? My Q is CV. It will be what? CV. Remember, Q1 is across what? C1. So this one will be what? C1V. Plus, this one will now be what? C2V. While the last one there will be what? C3V. You go back again. You can still change it back to V times CT. What is common to both sides here? V is common to both sides. I can bring the V outside. In the bracket, you have C1 plus C2 and plus C3. From here, this V cancel this V out. What am I left with now, student? CT equals to what? C1 plus C2 plus C3. So this is your formula for capacitance in parallel. Because if you look at some physics teacher, they only know that the formula for capacitance in series is 1 over C1, but they wouldn't prove it out for you. But it's better for you to understand how a formula or any formula in physics manage to get to this word. So I proved the formula out, capacitor in series, and also proved the formula out, capacitance in what? In parallel. So in a nutshell, this CT is still your what? Effective what? Capacitance. Or you can still call this your CT as your what? Your total what? Capacitance. And at the same time, you can still call your CT as what? Equivalent capacitance. But one thing you have to take note is that in physics, any question solved in physics, you must make sure you indicate your what? Your XI unit, which I told you that this your capacitance is always measured in what? Farad, which is what? F. But remember, if you're told to calculate charge, you have this your charge in your chemistry. When you talk about charge in your chemistry, which under your electrolysis, you know that charge is always measured in what? In coulombs. It's measured in what? Coulombs. Why this your V, which is your potential difference, is always measured in what? In volts. Take note. Now, since you understand that this is the formula for capacitance in series, and you have this one as capacitance in what? In parallel. So we can now pick one or two questions from JAMB past question. Let's see how to apply maybe capacitance in series or capacitance in what? In parallel to solve. But take note, the question you may be given that day may not be under capacitance in series. They may combine both parallel and series together. Let me give you something like this. Student, if you have a diagram like this, for example, if you look at this now, this one here, this diagram here, you can see that it's something like this. Yes or no? Definitely this one and this one here, they're in what? They're in parallel. This one here is in what? Parallel. If you now look at this, they are standing alone. This one also is standing in what? Alone. You can see which is your what? Your series. So that means this one here is in series. This one here also is in what? Series. Why this one also is in what? Series. But this one here is in what? Is in parallel. So let's pick one or two questions from the JAMB past question. So let's see how to apply using capacitance in series and capacitance in what? In parallel. Thank you. Still on capacitance of a capacitor. Question 1. From the circuit, we have something like this. That means we have 2 microfarad, 3 microfarad. Sorry, please. This one is 2 microfarad. 2. Why this one here is what? 4 microfarad. And at the same time, we still have what? As what? 4 microfarad. Calculate the total capacitance from the diagram. Illustrated above. Let's take a look at this. Remember, I told you that this one here is in what? Series. This one standing here also is in what? Series. Why this one here also is in what? Series. But these 2 microfarad, remember I told you that anytime you see this, you miss what? Macro. So this is 2 microfarad and this is 4 microfarad. If you want to solve it, don't stress yourself. Leave this one. Leave this one. Bring this diagram out. If you bring this diagram out, the one at the middle, remember you have something like this. Yes, understood? Remember you have what? 2 microfarad. And this one you have what? 4 microfarad. That means if I should bring this one out. Remember I told you that whenever you have something like this, that means it is arranged in what? In parallel. Are you with me? It's not up to 3, it is 2. Since it's up to 2, that means you have C is equals to what? C1 plus what? C2. Assuming it's up to 3, you have what? Plus what? C3. Whenever you have anything in parallel, since you have these 2 microfarad and this 4 microfarad, that means I have to sum the 2 together, which is going to be what? C equals to what? 2 microfarad plus 4 microfarad. So my final answer here will be what? 6 microfarad for this one at the middle. You can see that I've resolved these 2 and 4, giving me what? 6 microfarad. You now go back to this diagram back. You now redraw this diagram. You have what? 2 microfarad. Here you have 3 microfarad. Remember this one here now, you resolve it now, giving you what? 6 microfarad. This one now turn to 6 microfarad. And the last one you have what? 4 microfarad. You can see now the diagram now have it in what? In series. No more what? Parallel. Because I have resolved the one of the what? Parallel. Anything parallel, you sum it together. Are you with me now? So for me to have this in a series, this one will be what? C1, C2, C3, C4. And your formula for series, I gave you as 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over C3. Remember, it's up to 4, so you still have what? Plus 1 over C4. This is the formula to use to solve this thing now. So I cannot have, because this C here is your what? Your total what? Capacitance. Remember I told you that? That is total what? Capacitance. But it's not compulsory I put T there. So for me, I cannot have 1 over C equals to 1 over, what is my C1 there? 2. No need of you putting this microfarad, because that is the XR unit. Plus the second will be what? 1 over 3. While the next one will be what? 1 over 6. And the last one will be what? 1 over 4. So now you get into this place. Sorry, to some of you now, once you get to this place, the first thing you have to do is what? You find the word, the XCM. But some of you now, I know that some of you do find it very difficult to find what the XCM, but let me help you out. If you want to find XCM of something like this, you draw your line. What's the first number there? 2. Draw another line. What's the second number there? 3. You draw your line again. What's the next number there? 6. You draw your line again, Abby. And what's the last number there? 4. You now draw this. Now I can go. Your lowest number there is what? 2. If I should put 2 here, 2 divided by 2 is what? 1. 2 cannot divide 3 now. You still leave it as what? 3. 2 divided by 6 will give me what? 3. And 2 can still go in 4, which is what? 2. You can see 2 can still go again. 2 here will still give me 1. This one will be what? 3. 3. 2 divided by 2 is now what? 1. Next again, what can I use again? 3. This one will be what? 1, 1, 1, 1. So what are the number left there? 2 times 2 times what? 3. 2 times 2 is what? 4. And 4 times 3 is what? 12. So that means the XM of 2, 3, 6, 4 is what? 12. 1 over C equals to what? 12. You draw this your line. Now 12 divided by 2 gives you what? 6. So you're now using 6 to multiply the word in numerator. 6 times 1 will give you what? 6. And the next one again you go. 12 divided by 3 is what? 4. Use that 4 to multiply the numerator again, still gives you what? 4. Plus the next one will be what? 12 divided by 6 is what? 2. 2 times 1 will be what? 2. Plus the last one will be what? 12 divided by 4 is what? 3. 3 times 1 also still give you what? 3. So I can now have 1 over C equals to 6 plus 4, 10, plus 2, 12, and 3 will be what? 15 over 12. Please don't do that mistake. You're looking for C. Your C is what? Your total what? Capacitance. This is not the final answer. So you need to what? Cross multiply. This one will multiply 12. While this 15 will multiply what? C. So can I have 15 times C will be what? 15C equals to 1 times 12 is what? 12. For me, I can divide both sides by what? 15. Divide both sides by what? 15. 15 cancel what? 15. So what's your final answer for C? Your C is what? 12 over what? 15. Remember, the question we are given is what? Macro. I told you that this U is what? Macro. You put it back. So you now have it as what? 12 over 15 what? Macro what? Farad. Which is your what? Your answer for the what? For the total capacitance from the question given from the JAMB past question. I believe this one is well clear. Let me solve one more question under this capacitance. Arrange in series and also arrange in what? In parallel. Let me solve one more question before we now go back to what? The factors that affect what? The capacitance of the what? Capacitor. Because most physics teachers, they find it very difficult getting to that aspect. By the time they get to capacitance in series and parallel, in series and parallel, they stopped. Or yes, some teachers can still move further, going back to what energy was stored. But we're still going to solve questions under what factors affecting what? Capacitance of a what? A capacitor. P this should be Q. Sorry, please let me out. This one is what? 2 microfarad. 2 microfarad. This one here is what? 2 microfarad. And what do we have here? Please. 4 microwatt farad. You can see the English term they use here. They say find the net capacitance in the circuit above. But now, students, I want to put the option A. We have 8.0 microfarad. This is 8.0. Option B, please. 6.0 microfarad. Option C, 4.0 microfarad. Option D, 2.0 what? Microfarad. We have 2, 2, and this is what? 4. From your JAMB pass question, student, at times, some of you like something that let me just guess. If you're given a question like this, but don't be scared. Anytime you solve a particular question on the day of your exam, any exam, not even only JAMB, and at the end of your answer, you solve, maybe your answer is not among the option. Don't be scared. Because some of you are fond of doing that. Your answer may be correct. Because some of the options we have here may be what? May be wrong. Yours may be what? Correct. Don't be scared. You leave that one and go to the next question. But let's take a look at this. Remember, I told you that whenever something like this is standing alone. That means this 4 microfarad here is in what? Series. Remember, this one here is in what? Parallel. So if I want to solve this question now, this one now, give me something like this. This is your 2 microfarad. And this is your what? 2 microfarad. If you remember, I told you that I've resolved this one now, bringing it out from the diagram. This diagram here is illustrated in parallel. And I told you whenever anything parallel, you need to work to sum it together, which is going to give me C equals to C1 plus C2. So that means my C here should be what? 2 microfarad plus 2 microfarad. So with my final answer there should be what? 4 microfarad. So when you resolve this now, I can change this diagram back to P. You know, this one now turn to what? 4 microfarad. Sorry. 4 microfarad. And the other one there, you still have what? This is your Q. And this one you have what? 4 microfarad. You can see that I resolved this one now, giving me 4 microfarad. And I still have what? 4 microfarad. Now I've turned this diagram back to what? Series. So this one here is now what? C1. And this one here is what? C2. I remember that your formula for capacitance, you now have 1 over C total equals to 1 over C1 plus 1 over C2. So from here, can I have 1 over C total? 1 over, what's my C1 there, student? 4. While the second one also will still be what? 1 over 4. So from here, I can have 1 over C. That's XM of 4 and 4. We should know that XM of 4 and 4 is what? 4. We put it like this. XM of 4 and 4 is 4. 4 divided by 4 gives me what? 1. Use that one to multiply the numerator, still gives you what? 1. Plus 4 divided by 4 is what? 1. 1 times 1 on top again still gives you what? 1. So from here, I can now have 1 over C equals to 1 plus 1 gives me what? 2 divided by what? 4. Remember, I told you I can still reduce it, but let's cross multiply. I told you that 1 will multiply 4, 2 will multiply what? C. So 2 times C is what? 2C. And 1 times 4 is what? 4. I'm looking for C. You divide both sides by what? 2. Divide this one by what? 2. You can see these 2 cancel these 2. So my C there is what? 4 divided by what? 2. And 4 divided by 2 is what? 2, which is 2.0. So my final answer there will be what? C is equals to what? 2.0 macro what? Farad. Which of the option there today? Which is what? D. It's not hard. Are you with me? One thing you just have to take note in physics is that if we should understand how formulas manage to come in, if a teacher should be able to prove formulas for you, at the end of the day, you now see that physics is very, very simple. Very, very simple and straight. Because if you understand the formula, you'll be able to solve any questions. Any questions. So I believe the first question is well cleared. And the second question is well cleared. So after this, we'll go back to what they call the factors affecting what? The capacitance of a capacitor.